So the next topic will be focusing on factory methods that create streams. Remember from the patterns course that hopefully you took here at Vanderbilt, the concept of a factory method or a factory makes something. And that's just a good old gang of four pattern that's been around for decades at this point. And Java streams, like many other frameworks, is no different. They also use factory methods. And so factory methods are used in order to create streams. So there's a bunch of different ways to obtain a stream or to create a stream. One way to do it is to take a Java collection that you've made through some other means, like initializing it from a file or statically initializing it or getting input from a user interface or whatever means you use to initialize the Java collection, such as what we show here. So in this case, we're going to use the list.of factory method to go ahead and make ourselves a list of strings. And then once we have ourselves this collection, we can then use various factory methods to convert this into a stream. So here's a very simple example where we say words defined, which is our list of strings, .stream, and that goes ahead and will create a stream. And then eventually we'll convert it back into a list of search results, which we'll talk about later. This is the approach, of course, that we use in our simple search stream program. So if you go look at the program, if you take a look at the code I was walking through and visualizing, that's the starting point to convert a collection into a stream. There's other ways of doing this as well. There's another factory method called parallelStream that we've talked about briefly in other videos, other lessons. And basically what this does is it creates a parallel stream. So a stream that can be mapped to multiple processor cores automatically by the underlying streams framework. You can also create a sequential stream using something like words-defined.stream, and then before you reach the terminal operation, you can use the .parallel intermediate operation in order to be able to convert the sequential stream into a parallel stream. And interestingly enough, you can also, if you were so inclined, start out with a parallel stream and then somewhere along the line before you hit the terminal operation, call the .sequential intermediate operation and have the stream treated as a sequential stream. Why you would ever do that is completely mysterious to me, but it's possible. The thing to remember with the .parallel and the .sequential intermediate operations is whichever one of them occurs last before the terminal operation is hit will cause the entire stream to be processed by whatever occurred last. So if .parallel occurs last, it'll be processed as a parallel stream. If .sequential occurs last, it'll be processed as a sequential stream. And even if you were to say, .stream, .parallel, .sequential, .parallel with other operations in between, the last one always determines the actual semantics. And that's a little bit weird, but there's good reasons for it. And you can't swap back and forth in a stream by doing .parallel and .sequential. In contrast, when we talk about reactive streams later in the course, and we talk about RxJava and we talk about Project Reactor and so on, you'll see that they have methods like publish on and observe on that actually let you toggle the concurrency model as you're going through a stream. But that's not the way that Java streams work. That's the way that reactive stream implementation frameworks like RxJava and Project Reactor work. So for now, don't worry too much about this, but just be aware that that's something that can happen. You can also create streams from arrays. So if you have an array, like an array of strings here with A, B, C, D, E, you can say arrays.stream and then pass in the built-in array. Arrays is a Java utility class that has a bunch of methods that work on arrays, and there's one to convert a built-in array into a stream. And then once you've got that stream, you can do stuff with it, like you can print it out using a lambda expression or a method reference, and so on and so forth. There's also a static factory method defined on the stream interface itself. It's a static method that's defined there by default. And it can also take an array, a built-in array, in this case an array of strings, and convert that into a stream of strings, which once again, you could go ahead and print or do something with, iterate over, or whatnot, using for each or any other intermediate operations that you may choose to use or terminal operations. So the of static factor method on stream will also create a stream from an array. Here's an even more interesting static factor method that occurs with the stream interface. This one's called iterate. And what's interesting about this one, unlike things like stream or parallelStream that work on collections, or stream that appears on the stream interface or the arrays utility class, all of which work on fixed sized collections or fixed sized arrays so that the stream is fixed size. Iterate has the interesting characteristic that it can actually be used to generate infinite streams that, at least in theory, could go on forever if your program didn't crash at some point or you didn't shut it down. And we're going to show how to use the iterate factory method here to do something very interesting, namely create the first 100 Fibonacci numbers. So let's see how we can do this. This is pretty cool. So this program that I've highlighted here creates and prints the first 100 Fibonacci numbers, but the 100 is just something that we arbitrarily limited to. We could go forever if we wanted to, and I'll show you how to do that. So the way that iterate works is you give it something called a seed, and the seed is used to define the initial element in the stream. So here you can see that we say new big integer, and we make ourselves a 2-element big integer array where both big integers in location 0 and 1 are given the default value of 1. And that, of course, is how you sort of seed the Fibonacci sequence. And then we define a generator function, which is a lambda function that's applied to the previous element in the stream, in this case, starting with the seed, to produce a new element. And you can see what it does is it takes a lambda parameter, in this case f, which is the Fibonacci numbers, and it takes f, which is this 2-element array, and it creates a new big integer array where the first element, the element in location 0, has f sub 1, and the second element, namely an element sub 1, is f sub 0 added to f sub 1. And if you stop and think about it, that's basically how the Fibonacci sequence works. You take the previous number and you add it to the new number, or you create the new number by taking the first element and then adding it to the second one. So what will happen here is that this particular iterate call will generate an infinite stream of Fibonacci numbers that are stored in 2-element arrays. Well, that's actually not very useful because, number one, we don't want to do this forever. Number two, we don't want them as a 2-element array. We want them as just a stream of numbers that we can print out in order. So what we do here is we take the results of iterate, which is a stream, and we map it so that the 2-element array of big integers is converted to a single element stream output, which is just f sub 0. So we just take the first element in that stream. So now it's just going to be the Fibonacci sequence starting at location 0. And then we use limit. And limit is one of those examples of a short circuit aggregate operation. In this case, it's a short circuit intermediate operation. And what it says is keep track of how many items we've seen so far. And when we hit 100 elements, stop the stream. Do no more processing of the stream. So that's what's called a short circuit operation. And the last thing we do here is we give it a terminal operation. That, of course, is what's going to set all the wheels in motion. And in this case, what it's going to do is it's going to be the for each operation. And for each element in the Fibonacci sequence from basically 1 to 100, it's going to go ahead and call the system.out println method via the method reference that we pass in to for each. So remember that for each takes a consumer, and a consumer is going to accept a value, a parameter, and not return a value. And that turns out to match, of course, what println does. So just for kicks, if you want to run this program, copy it and run it, you'll see that indeed it generates the first 100 numbers in the Fibonacci sequence. And that's actually pretty cool because it's very declarative. You're saying what you want done. There's no loops. There's no if statements. There's no loop counter, all that other stuff that tends to go awry when you write more traditional imperative object-oriented Java code just disappears, and all you get are the behaviors that you want, that you declaratively ask for, the what, not the how. Make sure that you avoid using iterate in a parallel stream. There's all kinds of weird side effects that happen when you use iterate in parallelStream, and it tends to run very slowly. So please be careful not to do that. So that's an overview of some of the common Stream's factor methods. There's actually a whole slew more factor methods that we'll talk about in other contexts. There's things like split as stream and stream support.stream and many others. But these are the ones that you probably need to get started with and are the ones that will end up being used in the programming assignments that we'll have later in the course that focus on streams.